Hey everyone, welcome to the third OpenLaw demo. For those who haven't seen our previous demos, OpenLaw is a blockchain-based protocol for the creation and execution of smart, legally enforceable agreements. Using OpenLaw, you can create a legal agreement from one of our templates, digitally sign the agreement, and store those signatures on the Ethereum blockchain, and have a legal agreement interact with an Ethereum smart contract. This is our third demo, where we're going to explain to you how you can create a legal agreement that manages the sale of an Ethereum-based ERC20 token. To show this functionality, we're going to walk you through the creation and execution of a standard token purchase agreement, an agreement between a hypothetical seller of an ERC20 token and a purchaser. Let's go to that agreement now. As you can see, this looks like a standard agreement. The bulk of the agreement is written in familiar legal prose. Section 1 outlines terms related to the purchase, sale, and distribution of tokens. Section 2 and 3 contains representations and warranties on the part of the buyer and the seller. Section 4 contains a disclaimer and a limitation of liability on the part of the seller. Section 5 contains definitions, and Section 6 contains various miscellaneous provisions, including provisions that will become relevant when interpreting this agreement if there's a dispute going forward. Under the hood, however, this agreement's a bit different. It's marked up in OpenLaw's markup language, and as part of that markup language, it contains a call to an Ethereum smart contract, specifically this smart contract. What this smart contract will do is once this agreement is signed by relevant parties, it will manage the sale of the ERC20 token. Once the purchaser of the token remits payment to the smart contract for the tokens, it will facilitate the transfer of the ERC20 tokens back to the buyer. To see how this all works, let's fill out the fields and execute the agreement. Now the fields are filled in. As you can see, the agreement is being entered into between Super Token Supply Company and Token Fund LP for the Super Awesome Technology project. The name of the buyer can be changed on the fly. For example, we could change it to Jane Smith. We could indicate that Jane is not a legal entity, and I can change the language right here. Because the token purchase agreement uses our markup language, we can also build decision trees easily, enabling lawyers to change the language of an agreement to accommodate a sale to a legal entity. So we can revert back what we had before and see we've built a decision tree right here. Is the buyer a legal entity? If you indicate yes, a series of sub-questions emerge, and we can toggle between them to vary the language that appears in the agreement. And the reason we can do this is because our markup language enables parties to surface questions to an end user. Here, the question is the buyer a legal entity? And if the end user indicates yes, a series of sub-questions will emerge. Is the legal entity a corporation, an LLC, a limited partnership? And depending on the answer, we can change the text that appears in the agreement. So going back, we could change this to an LLC, and the text is changed on the fly. As you can further see in Section 1, the purchaser here is buying 10,000 tokens for 10 ETH. If the purchaser wanted to buy 100,000 tokens, we can recalculate that total amount on the fly because of our markup language. Our markup language is effectively a light programming language, and users can set variables and perform basic calculations. So we can set the purchase price as a variable here as a ratio between the total purchase tokens divided by 1,000. Same thing with the percentage of tokens. We can set that as a ratio of the total purchase tokens divided by the total token supply times 100. And in doing this, we can ideally reduce draftsman errors, assuming that the equation is appropriately set. So now that the fields are all filled in, we can send the agreement off for signature. We can review it, and when we're happy with it, we click send. And then we have to enter in the email addresses of the signatories. We use my email addresses for purposes of this demonstration. Once I click send, OpenLaw will send out emails to all the signatories for signature. So I'll hit send, and then I'll show you what that email looks like. This is an example of the email. I can simply click view and sign document, and it will take me to the document. I can look at the document, I can view it, and if it's acceptable, I can simply sign it. And a digital signature is being recorded to the Ethereum blockchain. I'm going to sign it from my other account now. After both parties sign the agreement, OpenLaw will trigger the smart contract governing the sale. To complete the sale, the buyer simply needs to send the promised Ether to the smart contract in MetaMask. We'll do that now. So we open up MetaMask. This is the Token Fund's Ether wallet. and we send an Ether to the smart contract address, submit it, and once that's processed, we'll see that tokens are credited to this account. So if we go back into MetaMask, we can see that this account has been credited with 10,000 super tokens, and it will take us to Etherscan, where we can see evidence of the fact that this occurred. You can see the quantity and all the transaction history right here. So what does this mean? First, using OpenLaw, you can facilitate the buying and selling of any tokenized asset using a standard legal agreement, decreasing legal risk that may manifest during token sales. If an ERC20 token represents a diamond, a barrel of oil, or any other type of asset, the sale of these tokens can now be tied to a standard legal agreement. Second, the seller of a token can use this type of smart contract to prevent unauthorized parties from attempting to purchase tokens during a sale. The smart contract is programmed to only transfer tokens to parties who have signed an agreement based on this template. Purchasers can't buy more than what is detailed in their individualized agreements, providing those who are selling tokens with more control over a sale. We're working on making it easier to transfer payments to a smart contract via OpenLaw, and we're devising some potential solutions to address this friction. Our next demo will begin to bring together some of the pieces that we've shown in our first 3 demos. Specifically, we'll be showing how you can use OpenLaw to create a whole set of documents, including a set of documents that work with an Ethereum-based smart contract. Stay tuned, and please do not take this demo as any encouragement or advice to engage in a token sale.